Hi, I'm Tommy Sanford. I'm in Mindanao right now in a rainforest. You can see the rainforest, it's right over there. Lived in Mindanao some 20 years before this, but I moved back to America and I sold everything because I got sick. While I was here, it was very difficult to know why people selected the houses like the ones across the street, Tantan's house. Why would they select that when they could have cement and it would last far longer and be far less money? The solution is complex, and it's not all because they didn't know how to build a concrete house. Taxes, titling, a lot of things factored into the kind of buildings they chose to build. I thought at the time it was mostly cement was very costly, so I tried to figure out a way to make cement a lot cheaper. The key, of course, is reusing your formwork a lot of times. And there's a lot of things. We'll talk about formwork for a little bit, about what destroys formwork. If you use just plywood forms, the cheapest kind of formwork for smooth walls, you have to consider that concrete is corrosive, and that if you soak your plywood into the concrete mix, the alkalinity destroys the fiber of the wood, and the result is delamination, even though the plywood is waterproof. There's a lot of other ways you can wreck formwork. Simply, it's poor handling. The longer it is in contact with the cement, the shorter time it will last. In other words, if you can strip soon, you can make your formwork last longer before the cement sticks to it, and you got to wedge the crap out of it to get it off. So there's a couple of ways you can avoid that. You can put a coating on the plywood. The cheapest coating that works well that I know of is A and B type epoxy, where you get 2 cans of mix. You mix the 2 cans together, and then you mix that up and make glue essentially. Then you add another 50% oil-based paint, and then you can spread that around, and that will prevent the alkalinity of the cement, of the concrete, to wreck your formwork. Wedging the formwork apart from a cast is also really hard on your formwork. So you can start off by first making your cast design so you can strip it easily. That would be no sharp corners, because the sharp corners, of course, the weakest part. You want to avoid a lot of patching afterwards. You want to get as good a cast as you possibly can as quickly. So you need to have a system where you can strip within, say, 4 hours of casting. You can also wreck formwork by filling it too quickly. And the stresses of the weight of the concrete, vertical weight of the concrete, end up overstressing the wood that it's made of. Also, if you take a look at my cast behind me, we have all these chamfered corners here as I step down. Now, everyone could make a cast that was 6 inches thick and full of bar and enough to where it would stop a D9. Of course, the idea is to make an economical wall. So I step this down. This is 5.5 inches this way and 5 inches that way. It steps down here an inch here. This is 3.5 inches thick, and this here is 2 7/8 inches thick. The idea is to save as much concrete as possible. I got, in each cast, I have approximately 11 cubic feet of concrete, or 2 sacks. I've noticed that when most people here use mixed cement, they do it by guess and by golly. And so the tendency is to put in way too much cement because they know the result of too little cement is unacceptable. So I made this cast. I decided how much I could make with 2 sacks exactly. The bigger the form, the greater the economy and the less versatility. That's why hollow blocks are extremely vertical. It's a very small piece of formwork. So this is my plastic coated. It had 4 ties. I can't see them here anymore, they're patched up. But there's 9 ties. 1, 2, 3, 1, 2, 3, 1, 2, 3. I used a piece of 3/4 bar with one end T-plate welded on one end. Your finger is up. Oh, see. So, and then I had it machined down to where I had about that much threads on one end down to 5/8. The splash gravel on it wears the threads out pretty quickly, so you can only do it about, a bar will only last maybe 50 casts. So a wood form unprotected, you're lucky to get 3 casts, good casts out of it, perhaps 6. I took care of my form work, didn't allow it to get rained on in the back. I glued the verticals to the 3/8 plywood. I got 58 casts here. Each cast contains about $20 worth of materials and labor. I designed my house so that it matched the formwork, not the formwork that matched the house. So this house is 4 casts by 3 casts. Step back over, Mom, so you can see the 4 cast side. So this little bit on the outside here was added later. They added a little store. Each cast is $20. That would be 4 casts. 4 casts this way, that's $80. 3 casts the other way, that's $60. So essentially I got all the walls on the first floor for under $300 for a 700 square foot house. And the same thing on the top. I got the cold joints. I arranged so the cold joints were always an intersection like this. It cuts way down the patching. If you had a cold joint here in the middle, you can't ever get it flat. It's almost impossible to patch nicely. Essentially, this is a beam at the top, and this is the curtain hanging down. Inside, it's got wire, 12 gauge wire, and the way you support the wire in the form is on the base of the form, so that when you handle the form, of course, it's going to pivot and it's going to tend to erode on the bottom. So I added a little block on the bottom, and then I drilled that block on an angle, and I took 20 penny nails and stuck them in the holes. Then I wrapped the wire around the holes and out the top of the form. So the wire is what connects the wall to the elevated slab. Then at the bottom, after you cast it, immediately you pull the nails out and the wire is abandoned in place. As you fill the form, you look down inside and you can see where to place the wire to make sure they're entrapped in the matrix. The columns have 4 10 mm rebar on the vertical and 3 bars, 1 at the top and 2 at the bottom, in the middle here. There's a ledge on the far side, 3 in the middle. So essentially this panel is hanging from that beam structurally. No one casts 2-inch slabs. No engineer, they don't cast 2-inch slabs. It's not because they're not strong. It's because they're very difficult to make sure you get quality engineering. Houses that fall down in earthquakes are big. Little concrete houses don't fall down in earthquakes. Very difficult because the relationship between the size of the particles, the size of the sections, and the size of the building concrete is just incredibly strong. This house, it was engineered by an engineer to withstand an 8-point. It would go a lot more than that. We've already had 2 earthquakes. This house is about 15 years old. We had 2 earthquakes already. One 7.3, which was about 20 miles that way, and a 6.1 directly under us. It's of course it's a volcanic place. There's a lot of earthquakes here. Wind, I don't even think it's relevant. You could have a 300-mile-an-hour wind, you would not blow it over. It's incredibly strong. The key is figuring out a way to make a lot of casts out of a durable form. So I believe that this house right behind me is the lowest cost house on earth if you consider how long it will last and how much it costs to maintain per square meter. Far cheaper than the one across the street, not even close. I'm particularly proud of my elevated slab. Let's take a look. Here's a cross section of the slab I built. Now this is actually a sequence of events to put this together. First off, since there's no lifting equipment here and no electricity when I built it, I had to construct it using the 2 men that I had. Now, I would suggest that you don't get a lot of men to help you because you end up filling your formwork too fast and breaking it all to hell. And too much time to give them training. It's hard to have non-concrete people understand the relevance and where the bar goes and why. But even so, I was determined to have people build this who had 0 carpentering experience, 0 concrete experience. And I made a lot of mistakes. Well, we made a lot of mistakes, let's put it that way. If I wish now that I have worked with people, I could start again and come out with a lot better finish. I had this idea to build this house, and it took me a long time. I didn't need a house because it's so cheap here. But I didn't need a house, but I wanted to try this. So that's my elevated slab. I cast these on gravel because I didn't have a casting slab yet. And they're just as long as a bar, as the bar I could buy. They have one 12mm bar down the bottom of this beam here, this 12mm bar. It's hooked together with, it's a vertical wire. So I tied the wires on the bar and cast it on the ground someplace to make a series of them. The reason why most contractors build a 4-inch slab is because all of the cost of building an elevated slab is in the shoring and the beams. So they have to build strong beams to carry the weight of the slab. I instead made very cheap beams and a very thin slab. So not only is this the least costly slab on earth, it's also the lightest. So here's how you build one. Cast these beams with the wires protruding out the top every 4 inches or 6 inches. So you go all along, you tie a 12-gauge wire to the bar, put a little cement in the bottom of the form, drop the bar into the correct position, wrap the wires out the top, fill it up, drop a thin bar, like a 5mm bar, 6mm bar on the top so you can lift the beam after it's set. And then take 3 guys, shove it over. Each beam weighs about 150 pounds. So then you shove it over the top of the wall. And after you have the beams in place, of course they're gumby as all hell. You can't hardly walk on one. They would support you. They're strong enough to support you, but they tend to go side to side. You have to be careful. Then I put 1/8 inch or 3/16 inch cement board on top of that. Then I got field wire. They call it in America. It's like hog wire fencing, a big roll of it. It's 100 meters for, I guess, 160 bucks. So that's $1.65 a square meter for reinforcing. I used two, that'd be $3 a square meter for reinforcing because I doubled it. So the next step is, after you get the little bits of 3/16 cement board, and you put it in between it, so you have this much beam exposed from the top, you know, like that, board, little pieces, the wire sticking up. Then you run the field wire, you roll it out, double, you know, one roll, another roll like this, right? Another roll like that. And then you cast about 3/4 of an inch of cement on the first one, just enough to where it covers most of everything. You can see on this edge over here, the first cast on the side. This is enough to bind the wire into the matrix. It's not enough to cover the wire. It's just enough to bind it. If you wait a day from that, now you can walk on all of this. It's all solidified. The beams no longer swing side to side as you in the middle.